In today's practical session, we will be discussing about the formulation of microemulsion. Our aim for today's experiment is to formulate and submit microemulsion. What is a microemulsion? What is the difference between microemulsion and macroemulsion? The name itself indicates microemulsion indicates the droplet size will be in micronized range. The physical difference between the microemulsion and the macroemulsion is the appearance, whereas the macroemulsion, the normal emulsion, will be opalescent, white, creamy in nature, whereas microemulsion is transparent or translucent, low viscous formulation. This is the major physical difference between microemulsion and macroemulsion. Now, let us discuss what are the requirements that are to be considered to prepare or formulate a microemulsion. The basic glassware required to prepare or formulate microemulsion is beaker, pipette, glass rods. The most important one is the use of equipments like shaking incubator and magnetic stirrer. Now let us see the theory involved in this formulation. The basic theory is microemulsions are thermodynamically stable, whereas macroemulsions are thermodynamically unstable. These are transparent in appearance, and the major difference is the use of emulsifying agents, whereas in macroemulsions will be making use of emulsifying agents, whereas here we'll be making use of a combination of emulsifying agents like combination of surfactants and co-surfactants. So basically, the formulation of microemulsion includes oil phase, aqueous phase, and surfactants and co-surfactant combinations. And the globule size ranges from 100 to 10 nanometers. These are homogeneous systems. Why? Because of micronized droplet size, these are evenly distributed and they are thermodynamically stable one. The major physical difference is these are low viscous formulations. Normally, the aqueous phase in the preparation of microemulsion includes ultra pure water. Ultra pure water. Whereas the oil phase of microemulsion generally includes ethyl oleate, isopropyl palmitate, isopropyl myristate, oleic acid, olive oil, or the combination of all these constituents based on the drug that we use. The third important constituent to be included is emulsifying agent. In this case, we'll be making use of a combination of surfactants and co-surfactants. The concentration of surfactants and co-surfactants that we use plays that we use in this formulation plays a major role. And what is the importance of microemulsion as a drug delivery system? When we are having microemulsion, what is the advantage of microemulsion over a macroemulsion? Microemulsion is thermodynamically stable and it has a small droplet size and are uniformly distributed across the dispersion medium. And these are considered as drug delivery system of its greater stability. And because of smallest droplet size, these can be easily sterilized by ultrafiltration technique. And what is the use of this microemulsion and how this microemulsion can be used as a drug delivery system? Now for this, let us consider here. We'll see, for example, this is a beaker and this has small droplets dissolved in water. And if we load these oil droplets with drug and if we dissolve drug in the oily phase and dispersed in the aqueous phase, now we get oil droplets loaded with the drug particle. And from this drug particle, the drug from this droplet loaded with the drug slowly gets dispersed through the film across the oil droplet and the aqueous phase that acts like a barrier, and thus we can actually control the drug release from the droplet. And also, if we are considering oil as internal phase, and if our drug is lipophilic in nature, we can dissolve our drug in the oily phase, and that's how we can improve the solubility of a drug, and we can administer the drug in a suitable dosage form like oil in water type of emulsion. Now let us see what is the principle involved in this experiment. Microemulsions are transparent, these are clear solutions, these are used or prepared by a simple mixing of all the ingredients. The technique used in this formulation is oil trituration method. And here the oily phase includes ethyl oleate. In this experiment, we will be considering ethyl oleate as our oil phase. And the aqueous phase is ultra pure water. The most important point is the use of emulsifying agent, the use of surfactants and co-surfactants in specific concentrations. Whereas here, we will be making use of PEG 8 caprylic acid or capric glycerides in specific concentrations as emulsifying agent. The most important thing is the equipment used in this formulation. This is the most important one, and that is shaking incubator. Shaking incubator. After formulation of our microemulsion, the emulsion is subjected for stability studies. But for today's experiment, we'll be discussing about the formulation of microemulsion, how we are making use of this shaking incubator to formulate our microemulsion. In today's experiment, we will be discussing about the formulation of oil and water type of microemulsion. For today's experiment, we'll be making use of shaking incubator, and the shaking incubator looks like this. This is a temperature controlled. In this, we'll be having a platform over which we will be placing our beakers. This is a platform which moves to and fro, over which we will be placing our beakers or the conical flask with either oil phase or the aqueous phase. And here we will be having settings for or to control the temperature in the cabinet. Now this is the basic setup that is used to prepare a microemulsion, where a specific temperature can be controlled in the working environment. Because most of the emulsion preparations, we need to control or we need to maintain the temperature of oil phase and also aqueous phase. Now let's get into the procedure. The procedure to formulate a microemulsion. In this, we will be making use of a technique called oil trituration method. It is oil trituration method. Now, first of all, we need to make our definite concentrations of surfactants and co-surfactants of varying concentrations. Say, for today's experiment, we will be considering surfactant co-surfactant ratios that are ranging from 1:1, 2:1, 3:1, 4:1, 5:1, 6:1, 7:1. We need to make specific solutions of surfactant and co-surfactant combinations by taking surfactant and co-surfactant ratios ranging from 1:1 to 7:1 by using or by dissolving in the aqueous phase. So our aqueous phase is now ready with dissolved emulsifying agent. Here the emulsifying agent we use is the combination of surfactant and co-surfactant. Now we are ready with the aqueous phase. Now, thus added emulsifying agent to aqueous phase is subjected to magnetic stirring, of which 1250 rotations per minute is maintained for 10 minutes. Now dissolve emulsifying agent in the aqueous phase, that is ultra pure water, and subject it to magnetic stirring by means of magnetic stirrer. The speed at which magnetic stirrer is to be maintained will be 1250 rotations per minute for at least 10 minutes till we get opalescent liquid. Now we are done with the preparation of our aqueous phase, right? Next, we will be discussing about the preparation of oil phase. Now, take oil phase. In this experiment, we'll be making use of ethyl oleate oil phase. To this oil phase, we will be adding drug because the drug of our choice in today's experiment would be lipophilic drug. Dissolve the drug in the ethyl oleate to get a solution or a saturated solution based on the concentration of the drug which we use in the formulation. Normally, we need to dissolve the drug in the 10 grams of oil phase to get a saturated solution. Now this solution is subjected to constant stirring at controlled temperature. So we will be making use of an equipment called shaking incubator. So we'll be placing over shaking incubator for a time period of 72 hours. The most important point is the temperature at 37 plus or minus 1 degree centigrade. So this is the major step to be considered, where we'll be making use of shaking incubator. We'll be placing our drug dissolved in the oil phase and is placed on the shaking incubator for 72 hours. Should be under continuous stirring and is maintained at 37 plus or minus 1 degree centigrade. This is the major difference in the formulation of microemulsion and macroemulsion. Whereas in macroemulsion we'll be maintaining the temperature at not less than 60 degrees centigrade. It will be 60 to 65 degrees. Aqueous phase will be maintained at 65 degrees and the oily phase will be maintained at 65 degrees. Whereas in this formulation of microemulsion, we will be maintaining the temperature at 37 degrees plus or minus 1 centigrade. Now we are ready with the oily phase after 72 hours. Now here the next important step is addition of oily phase into aqueous phase having surfactants. The most important note to be considered is oily phase is added dropwise to get uniformly sized droplets we need to add dropwise. Oily phase is to be added to aqueous phase. And it is the most important step where the droplets will try to form. So this is under continuous stirring. Now we have taken this oily phase out. We are adding the oily phase into the aqueous phase, which has undergone magnetic stirring. Now when we are adding drug to the aqueous phase, droplets are being formed, and at this phase the surfactants present and co-surfactants present in the aqueous phase act as emulsifying agents, and they form interfacial film between oil phase and the aqueous phase. And the difference between the interfacial film of a microemulsion and macroemulsion is its flexibility. In microemulsion, the film would be more flexible. More flexible film is formed because of the combination of surfactants and co-surfactants. So likewise, while we are adding oil phase into the aqueous phase, it should be under continuous stirring. The aqueous phase should be under continuous stirring. Now the oil, we need to make sure that it is under continuous stirring, and till the process is continued till we get a clear and fluid formulation is obtained. So as soon as we get completed with the addition of oily phase, we'll get a clear, translucent or transparent formulation. Now thus obtained microemulsion formulation is stored for 24 hours at room temperature. Thus obtained microemulsion is actually exposed or subjected to evaluation studies like a stability study for its globule size distribution study, for its viscosity, it should not be too viscous, for its pH, for its type of emulsion, whether for example if we are supposed to prepare oil in water emulsion, and during our evaluation study we need to observe whether the emulsion thus produced is oil in water or water in oil. We need to get the report as oil in water. Suppose if we get water in oil, means there is some instability that has undergone during its storage for 24 hours, and because of some thermal instability it might lead to phase inversion. So to know whether the emulsion is a stable one or not, we need to subject that emulsion for the evaluation studies, and also it should be evaluated for the drug release studies also. The most important one for a pharmacist to remember is how much emulsifying agent is to be used to get a stable formulation. Normally, the total surfactant quantity, here includes total surfactant quantity here implies to the surfactant and co-surfactant. So the combination of surfactant and co-surfactant should be 60% or higher based on the formulation. Generally, the total surfactant quantity required to get a stable microemulsion would be 60% or higher than that. And in the experiment, we have used different combinations of surfactant and co-surfactant, like that ranges from 1:1 to 7:1. Out of all these combinations, it was found that the 6:1 ratio has given a stable microemulsion. So this type of inference we can get is only through trial and error methods. We need to formulate the microemulsions by making use of various combinations of surfactants and co-surfactants so as to check which concentration is suitable to get a stable one. In this experiment, based on the journals, on the publications, we have seen that the surfactant and co-surfactant in the ratio of 6:1 is found to produce a stable formulation. In this experiment, the surfactant co-surfactant used is the combination of polyethylene glycol 8, caprylic acid and capric glycerides. Now let us see what is the basic formula to be considered to formulate a microemulsion. The basic formula, the basic general formula for microemulsion. Now here, the basic formula here we will be discussing in terms of percentages, so that this basic formula can be applicable to any of the quantity, be it for 5 ml microemulsion to 1000 ml microemulsion formulation. We can actually expand this formula. So hence this general formula is given in terms of percentages. For in case if we want to incorporate drug, we should make sure the drug should not exceed 2%. And the oil phase which we use should be in the range of 5 to 15%. Water or the aqueous phase should be in the range of 35 to 45%. And surfactant co-surfactant should be in the range of 45 to 60%. Now here we are discussing about oil in water type of microemulsion. These quantities, these ranges will vary based on the type of emulsion, whether it is oil in water or water in oil. This is the basic formula. Now we will be discussing about the formula which we use for today's experiment. The oil phase is the ethyl oleate. Water phase is ultra pure water. Surfactant, co-surfactant are polyethylene glycol 8 complexes. And now we have considered 3 formulations, like formula 1 has 5:1 ratio of surfactant co-surfactant, and formula 2 will be 6:1, formula 3 is 7:1 ratios. So 5:1, all these 5:1 parts should be of 57% of the total formula. Understood? Now here we are discussing about, here we are checking the stability of a formulation by considering different concentrations of surfactants and co-surfactants. And at the last, the surfactant co-surfactant concentrations should be of this range. So this is about the formula. So after we get the transparent stable microemulsion formulation that is subjected to physical, thermodynamic stability and drug release studies, and thus the evaluation data is obtained, and we need to check whether the formulated microemulsion is stable or not. If it is not stable, we need to change the formula so as to get a stable one. That's how we need to change these ratios to get a stable microemulsion. But for in this experiment, we'll be just discussing about the formulation. How can we formulate the microemulsion? What is the basic theory and principle involved in the preparation of microemulsion? And thus, done experiment is reported. Microemulsion of the given drug is formulated by use of varying concentrations of surfactant and co-surfactant by taking ethyl oleate as oil phase, ultra pure water as aqueous phase. We have formulated, and we need to report at what concentrations we got a stable emulsion. And that concentration, that percent, we need to write it down, whether it is 5:1 or 6:1 or 7:1. So that we can decide based upon the evaluation studies or based upon the physical appearances. So we have, after finishing with the preparation of emulsion, we have kept the emulsion for 24 hours standing. So at the end of 24 hours, we'll be checking for its physical stability, whether creaming has occurred, whether a separation of phases have been observed or not. So based on that, we can write it down. We can note down the basic stability situation of the formulation. And that's how we can formulate a simple microemulsion in the laboratory scale by making use of varying concentrations of surfactants and co-surfactants. So this is about today's experiment. If you have any doubts, you can ask me through mail. Thank you.